Hey everybody, this is Mr. Storm, and in this video we are going to create a couple of camera systems for our game. So just as a review, so far what we've built is a character controller. Our characters can move around the game, but they can't really do much, right? Because if I try to leave this area, I can leave, but the camera doesn't follow me. So we need to fix that problem. Now, there's one very easy way to fix this issue, but it's not exactly what we want. Let's think about how cameras work or how objects work in Unity. This main camera, if we were to, say, make it a child of the player object, then it will follow the player object no matter what we do. So we can play the game and we can see that it will follow the player object no matter what, right? And our character will stay pretty much right where it starts on the screen, and that is an easy way for us to fix this issue. But we want something a little more advanced than that, because I want to be able to have more control over how my camera looks, right? So what I'm going to do is I'm actually going to unparent that, meaning I'm going to make it its own unique object. Again, it's no longer tied to the player object. And I'm going to add a new script. I'm going to create a new C# script called camera controller. Okay. Now there's a pretty advanced system that we could use in Unity called Cinemachine, which quite frankly is a really powerful tool, but I'm not going to get into it in this class. If you want to learn more tutorials about Cinemachine, you can definitely find those on YouTube. I'm going to show you the script-based way of creating a camera system. Okay, so in our camera controller script, let's think about the variables we're going to need. And we're actually going to need quite a few for this script. The reason why is because I want to have a lot of control over my camera system, and I don't want to have to come back into my script to change them. So these are all going to be public variables. So the first variable we need is a transform of the tracking target, basically the object that we want our camera to follow. For us, it's going to be our main character. The next thing we want is we want an offset on the x-axis. So we'll say float x offset. Then we want an offset on the y-axis. So what this is going to do is it's going to allow us to move the camera left or right in relation to the main character that we're following. It'll allow our camera to kind of position itself properly. Next, we want a follow speed. So float follow speed. Maybe we don't want our camera to exactly follow our character perfectly. Maybe we want there to be a little bit of floatiness to the camera. So we want to be able to change that. Let's create a public Boolean, and let's say is x locked. We'll set it equal to false to begin with. Now what this is going to do is it's going to allow us to check a box that then locks our x-axis on our camera. And we want to do the same thing for is y locked. And again, this is going to allow us to lock our y-axis in the camera. Then the last four variables we need are all floats, and they're going to set the minimum and maximum positions on the x and y for our camera. So min x position, max x position, min y position, and max y position. This will allow us to set boundaries outside of which our camera cannot travel. So those are all the variables we'll need. After that, the script gets pretty easy. So let's go ahead and get rid of the start menu here, or the start method. We don't need that. And in our update, the first thing we want to do is we basically want to have our camera lock on to our tracking target, but also apply the offsets. So here's what we're going to do. Float X target is the tracking target dot position dot X plus X offset. Okay, so it's going to take the position of the thing that we're tracking, and it's going to apply that X offset that we set so that it pushes it left or right on the X axis. So the camera's not directly centered on the character. We'll do the same for the Y. Float Y target, tracking target dot position dot Y, and we'll set it to the Y offset. Okay, so that's going to allow us to, again, push our camera up or down based on the offset that we set for how off from the center we want the camera to be. Okay. Then we also want basically the new, so every frame, there may be a difference between the main character and the camera's position. So we want the new position of the main character so that, or we want a new position of the camera, excuse me, so that we can then make them match up over time. We don't want to do it immediately. We want it to match up over time because we want a little bit of floatiness. So we'll say float X new equals transform dot position dot X, and float Y new. Why do I keep spelling float incorrectly? Y new equals transform dot position, oh my gosh, dot Y. I can't spell at all. Okay. So now we want to check to see if our camera is locked. If it is, we want to make sure that nothing happens, right? Which we will do. We'll handle by basically creating an if statement. And you know what? Actually, let's do an if statement that says if it's not locked, then we're going to actually make the camera move to match up with the parameters we've set. So to do that, we'd say if exclamation point is X locked. So what that means is that's basically saying is X locked is a variable. It's a Boolean. The exclamation point means not. So if not is X locked. So basically if is X locked is false, then we're going to allow for this next thing. We're going to say X new equals math f dot lerp. So lerping, what it does is it's a linear interpretation, or lerp, right? Lerping will interpolate between two different points linearly, not exponentially, but linearly. So it'll give us a steady interpolation between two different things. So we need to put in the first point and then the second point, and then we need to put in the time that we want that interpolation to happen. So the first point is transform dot position dot X. The second point is going to be the X target. And the time that we want it to happen is time dot delta time. Delta time is basically just going to calculate how much time has passed since the last frame, and it's going to smooth out your time a little bit. So time dot delta time, and we're going to, time dot delta time, and we're going to multiply that by follow speed. Okay, so that means if our X is not locked, then every frame we're going to do this lerping function, which is going to move our camera toward our main character, or at least toward where the main character, where the parameters are set for how we want our camera to match. And it's going to do this at a certain time. Okay. Now, all we have to do is let's copy this. We need the same thing for our Y value, right? So in here, we just replace X with Y. Is Y locked? And then we'll say Y new, the position dot Y, we'll set a Y target, and everything else is the same. Okay. So if X is locked, then that movement won't happen. If Y is locked, that movement won't happen. All right. So we've locked our stuff. Now the only thing we have left to do is to clamp our camera position in between the max and the min. So we can say y new equals math f dot clamp. And clamp is basically going to just give a range. It's going to allow us to set a range and make sure that that value never grows out of that range, either positive or negative. So the value we want to clamp is x new, and the lowest number on the range is going to be min x position, and the highest number on the range is max y or max x position. All right. Now, as you probably guessed, we can take this line of code here, we'll copy it, and we'll paste it here. So, and again, y new, min y position, max y position. Okay, so now we have everything. We just need one more thing. All we need to do is update our transform position for the camera so that it goes to the new position. All of this, what all this code was doing was just calculating what the new position is going to be. That's it. That's all we've done. So what we're going to do is say transform.position equals new vector 3. Now we have to use a vector 3 because cameras in Unity are all 3D objects. So if we just give it 2 values, it wouldn't work. It's looking for 3 values, an x, a y, and a z. So we need to give it 3 values. X new is the x value, y new is the y value, and the z is going to just be transform dot position dot z. Okay, that is our entire camera follow script. Let's go ahead and send that to Unity, and let's go make sure it's all set up properly. So our camera controller script, we haven't actually attached it to our main camera yet. Let's do that. So now when we look at our main camera, we have a ton of these things that we need to fill in. Our tracking target is going to be the player. Okay. I'm going to keep the X and Y offset to 0 for now so you can see what it looks like. I will set the follow speed to 1. I'm not going to lock the X or Y, but I do want to set minimum and maximum X and Y positions. The reason for that is because I want to make sure that my camera has minimum and maximum positions it can play with. Now, the way I've designed my game, it may not actually matter. But what I could do is I can set, like right now, the camera is at 0, 0. Okay. So I can say 0 is my minimum X position. My maximum X position, though, will have to be somewhere around there. We'll say 38, 37. So my maximum X position is going to be 37. Okay. Now let's find the lowest position on my level. And I think I'm pretty much at the lowest position. So we'll say the minimum Y position is going to be there. And let's find the maximum Y position in my game. Probably right about there. So we'll say the maximum Y is 5. Now what this is going to do is it's going to keep my camera from moving outside of those parameters that I've set. So let's go ahead and play and see if that's working. Okay, so my camera is following me and it gives a little bit of that floatiness and it won't go any farther past that spot that I've set, right? Okay, so now this is causing a little bit of an issue just because my follow speed isn't fast enough. Let's set it to 5 and see what happens. Okay, now it's following really, really well. But I can tell there's a little bit of a catch-up afterward, which makes it feel kind of more realistic. I like 5. 5 is good. And my camera's not going above that highest point. Okay, perfect. So this really already feels like an amazing camera system. And I'm really happy with it. This is fantastic. Now, let's say you have a level that is not very vertical, right? You can turn on, you can check, is Y locked? and turn that on, and then lock your Y value. So your Y value never changes. You can do the same thing for is X locked. If you have a vertical level where you're not moving back and forth on the X axis. I wrote this script to be as versatile as possible for every different kind of level that you might create, right? Now, let's talk about the offset a bit. So the offset, I didn't reset the follow speed to 5. Okay, let's go back into it. So let's talk about the offset. Right now it looks kind of normal, right? Because I'm in the middle, or I'm on the game, or let's go back down to this lower platform. So I'm on the lowest platform. My camera can't go any lower than it is right now. If I come up to this middle platform, notice I'm pretty much dead center in the middle of the screen. If I come up here, the camera comes up to match it. But here's an issue. With some games, you might actually want your camera to be a little bit more forward than backward. So let's say I want to give it a value of 2 for the offset on the X axis, which means I want to see more of what's in front of me because I'm mainly moving forward than I am going to be moving backward, right? That's something you can do using that X offset. We can do the same thing with Y offset as well. Maybe I want the camera to go just a little bit more, let's say 1.5, right? I just want it to be a little bit higher up so I can see more of this side of the screen, because my enemies and the things I'm looking for are going to be coming from this area here. So the more of this I can see as I'm running around, the easier it's going to be for me as the player to see the rest of the level and see what's going on, right? So again, that's why the offset values are there for you. It communicates to your player that there's a direction they should be traveling, right? Now, some games where maybe there's a lot of left and right movement, and you can go back and forth, some games won't have an X offset or a Y offset even. But that's why this script is so valuable, because it's versatile and you can change it for whatever you want. Okay, I'm going to put in those values again because I kind of liked those values that I picked for the offsets. Okay, now there's another thing that we need to do. We need to we need to work on our parallaxing part of the script. Now, I'm already past 15 minutes, so this is going to be, I'm going to kind of rush through this, but this is going to be a longer video. I'm just letting you know. I'm just looking at the time here. It's going to be a bit longer than I expect, but that's okay. First thing I want to do is I want to bring in, where are my resources? Let's go to my desktop and Lonely Robot Assets. Here we go. I'm going to bring in my sprites for my background object. So I have this background here. I have my foreground and I have my midground. So I'm going to bring those 3 in so that we can get these working. The background is going to be easy. You'll see why. But what I'm going to do is, before I get too excited about this, I'm actually going to set up these sprites so that they fit exactly in my game. So I'll say my pixels per unit is going to be 32. I'm going to turn off the filter and turn off compression and hit apply. Okay. Now the background is going to be pretty easy to implement. We're just going to drop it into the game. We'll set it at 0 on the X, 0 on the Y, and we will set it to -20 in the order in layer. Then all I'm going to do is I'm going to set it as a child of the main camera. Now what that means is, now when I'm running around my level, my background is there and it stays with my main camera no matter where I go. Okay, perfect. So that's my background. That's super, super easy. The next thing I want to do, let's play with my midground a little bit. So the midground is going to be a bit different. I'm going to need a script to handle the midground. You know what? This is fine. For now, this is fine. Let me create another video. I don't want this to be too long. let's create another video that gets the parallaxing moving so that, you guys can separate this out. All right, so we got the camera controller, camera follow script working in this video. In the next video, we will deal with parallaxing. Okay, perfect. That's a good plan. I don't want this to be too long. All right, I'll see you guys in the next video where we deal with parallax. All right, peace.